Hi, everyone. We're the Forecasting Heavy Rainfall with Deep Learning team. My name is Suhaib, and my teammates are Arthur and Mon. So as we all know, forecasting the weather can be pretty difficult and computationally or financially expensive, and oftentimes our forecasts are not all that accurate. And this is a particular problem when we have extreme events like hurricanes or flash floods, and those events can threaten people's lives or people's property. This is especially a problem in the Southeast US. So our project aims to develop a way to forecast extreme weather events in the Southeast US in a more accurate way, and also in a way that's more computationally and financially efficient, and it can also be generalized and uh, brings really more accuracy to traditional forecasting methods. So our data consists of two parameters. One of them is called DBZ, otherwise known as reflectivity. That represents the intensity of rainfall in an area or the cloud cover pretty much. The other is called ZDR, otherwise known as drop size distribution. And that basically tells us whether we're dealing with rain or snow or hail, or basically what kind of precipitation is in that area.
The model we are using is called FearNet. It's a model based on a model called UNet. It's actually a neural network model. It's good to capture both spatial and temporal pattern for extreme weathers. And compared to UNet, it's easy to calculate and it has better accuracy.
Next, we feed both of our input variable, which is ZDR and DBZ, to our FearNet model in order to produce 40 minutes forecast. You can see on the result fiction on the left the predicted output. It looks slight compared to the actual output, but overall intensity looks very good. And the plot under it is the training and validation loss plot to indicate if our model is overfitting or not, and it's not overfitting.
So a couple other statistics about our 40-minute forecast that we did. Our hit rate was pretty good for the lower DBZ threshold. We have two different DBZ thresholds here. One of them represents lower rainfall, and one of them is for the more extreme rainfall. For lower rainfall, it was quite accurate. Our hit rate was 84%, a low false alarm rate. And our HSS score, which basically represents how much does our forecast, how much better is our forecast than just a random forecast. It seems like our forecasting was much better than random, which is good. Our predictions for the for the more extreme rain was a little bit worse, but that's to be expected. We still did pretty good. In terms of using the data, our data available for training, we had a lot of challenges with our project about basically having too much data to work with, or so much data that was kind of hard to work with. If we trained with only the days that had heavy rainfall, out of the 3 months of the year that we used, we got an evaluation score of 53%. And then if we used all the data of the 3 months, it actually went down, which might not be what you expect. But we attribute that to our model being overfitted previously. And so adding more days gave us, even though the evaluation score went down, it gave us a more useful forecast. If we added a ZDR as a second parameter, as we had mentioned before, our evaluation score goes up a lot.
Yeah, and it comes to our conclusion. So the deep learning model, the FearNet model, actually demonstrated really good results, and it actually do some. Since the traditional model only produced linear regressions results, and our model, and since actually a lot of the atmosphere process is not linear, and our model can have a better capture of that. So that's why we have a really good result, which is 76% accurate. And we also successfully captured the spatial and intensity pattern for the rain evaluation. And finally, we have successfully integrated those radar data to enhance the prediction. There are some things we need to do to improve our model in the future. So we need actually more data and more storage for our prediction, because it's performing really bad after 1 hour's prediction. Or maybe we can just add some new parameters to improve our model. And that's all for our presentation. Thank you very much.